Here we have an application problem where we're asked to essentially solve this absolute value inequality. That's already been set up for us, but by solving it, it will help us determine the acceptable lengths of this particular rod. So to solve an absolute value inequality or even an equation, I like to remember that what's inside the absolute value could be positive, negative, or zero. So what I do to account for that is I consider both a positive case, where what is inside is positive, and then I consider the opposite of that happening, so that negative case inside this absolute value. So that's what could be inside. In other words, I'm just expressing all the different possibilities, thus being able to rewrite it without having to write the absolute value. From here, you have lots of options how you choose to continue solving this. Well, maybe not lots of options, but you do have some different options. So for instance, like in this problem, I really don't need the parentheses. I can essentially ignore them and add 5.5 to both sides in order to finish solving that inequality. For this other one, I could choose to divide both sides by -1 first. But if I do that, I must switch the direction of the inequality in the next step, and as well then add 5.5 to both sides to finish solving that. And what these values tell me is this threshold, this lower and upper threshold that would create the acceptable lengths of this object. So the lower threshold being the 5.4997, that value would go here, and the upper one being this one, the 5.5003.